Hello and welcome to the Corporate Facility Council's first Wednesday webinar, How Facility Managers Can Leverage Solar for Financial Gains, presented by Suparna Kadam and Matt Elmore with Pivot Energy. I do want to let everyone know they have been muted for audio quality. If you have any questions during the webinar, please feel free and type them into the question box, and we'll be more than happy to go over them during the Q&A portion at the end of the webinar. This webinar is being recorded and will be available on the CFC's website, ifmacfc.org. At this time, I want to thank the newest CFC sponsor, Pivot Energy, for providing this presentation for this month's First Wednesday series webinar. Our presenters today are Suparna Kadam. She's Senior Business Development Director with Pivot Energy, focused on providing enterprise clients with comprehensive solar and storage solutions with a compelling long-term ROI. Pivot Energy develops, finances, builds, and manages community and commercial solar and storage projects around the country. She has 15 years experience in the solar energy, and she holds an MS in chemical engineering and an MBA from MIT and a BS chemical engineering from Cornell. Matt Elmore manages the Denver office for Pivot Energy and leads business development for behind-the-meter projects and community solar subscriptions. He has 9 years experience in the solar energy industry. Previously, Matt was the solar project manager lead at Elevate Energy in Chicago and led business development for solar energy and energy efficiency projects at Christensen Electric. And that was in Portland. He graduated with a BA in philosophy from Colorado College in 2009. At this time, I'm happy to turn it over to Suparna and Matt. The floor is yours, guys.
Thanks, Joshua. We appreciate the introduction and the opportunity to speak with the group today. I'm going to start us off with an introduction about our company, as well as just a solar energy 101, and then Suparna and I are going to switch off as we go later into the presentation. Just a bit more background, as our introductions said. I'm the VP of Business Development here at Pivot Energy. I manage our team that leads all of our behind-the-meter on-site solar energy development. And I've been in solar, I think I need to update my bio. I've been in solar for 12 years now, so that's a little outdated, but been pretty much focused that entire time on on-site solar energy, and we'll get into exactly what we mean by that. Suparna, do you want to add anything else about yourself before we get underway?
No, all set. Like Matt, have been in the industry for a while and have seen a lot of different parts of it, so can also answer questions on the technology side later if people have more they want to know.
Great. Okay, I'm gonna get us underway on the presentation here. Let me make sure I can guide us. Okay, so we're going to cover three main sections. We're going to talk just very briefly about company background, just so you all know exactly who we are and what perspective we're coming from. Talk a little bit about what type of projects we focus on. And then we're going to do, as I mentioned, a solar energy 101 overview, which we hope will be helpful. That'll cover just the basics and get into some detail on solar PV technology, different types of roofs and materials that we come across. We'll talk a little bit about energy storage and other topics that customers bring up to us quite a bit. Then we'll get into a really important section on financial metrics, talk about incentives and related solar energy rebates. And then we'll talk about a few case studies and some advice on how to begin your solar energy process if that's what you want to start this year. So a bit about our company. We were founded in 2009, originally in St. Louis, but we actually now have headquarters in Denver, where I'm based, and Suparna is based in New Jersey in the Northeast. We've done hundreds of solar energy projects since we were founded, more than 800 in 18 states. And we've had, if this means anything to anyone, we've had more than 150 megawatts built and an additional several hundred megawatts in the pipeline that we expect to be built in the next few years. Well, I'm based in Denver and Suparna's in the Northeast. We do have staff and offices in St. Louis, Chicago, New York City, DC, and LA. So coast to coast services. We really are a national turnkey solar energy provider. We focus on site for my team, but we do have a community solar team, which is an offsite solution, which we'll talk about and get into a little bit. And we focus really on commercial and industrial, which is not super accurate in covering all of our customer types, as we do also nonprofit entities like municipalities, schools, hospitals, anything that's non-residential. You know, we don't do single family homes or small apartment complexes, but anything larger than that is what we focus on. As far as our investment, it's important to note that we have an investment and internal project financing fund from a company called ECP. That's one of the larger private equity funds in the country for renewable energy investment, and we're excited to be a partner with them and to be able to own projects long-term that we develop for customers. So moving on, in terms of what we do as a company, and we'll talk more about this as we go along, but we like to break it up into on-site and off-site renewables. For the majority of you on the webinar today, on-site's probably more applicable, but we did want to mention off-site because that is a growing portion of the solutions to hit renewable energy procurement goals. So we'll talk about that a little bit. We won't go into as much detail as on-site, but something we did want to mention. And as far as on-site is concerned, we're going to talk about solar PV projects, a little bit about energy storage. That's a pretty hot topic these days. We'll also talk about the project financing that can come along with these type of projects. So a little bit more about what we do, and this is instructive for how to think about the whole life cycle of on-site solar energy systems. It's really what we consider a 5-step process: development, financing, engineering, construction, and management. As a company, we do all of these, but you can think of them as the stages, the helpful stages of developing any solar energy project at your facility. We're going to get into each of these stages here in a bit, but we just wanted to call these out, and I'm sure these slides will be distributed to the group. These are all essential to developing a reliable and feasible solar energy project for your facilities. In terms of just noting some of the initial stages, really development is the whole feasibility process. That encompasses both technical and economic diligence, which are equally important parts of our projects. And that can be anywhere from a month or two to a year, depending on how complex and large your project is. That's really key and important that you bring a trusted developer and contractor along at that stage in the process. We'll cover financing possibilities a little bit later, and then the last three are really engineering once the project has been finalized in terms of size and technical specifications, construction, and then post-construction management are all important steps to the solar energy project development lifecycle. Real quick, not going to dwell on this too much, but we have a number of different customers. Like I said before, we have national corporations, we have local nonprofits, cities, municipalities, educational entities, private and public. So anything that's non-residential is what we focus on as a company. Before we dive into how solar energy works, just a quick summary of how it can benefit you as a facility manager, regardless of what specific facilities you are indeed in control of. These are the main four. There's certainly quite a few others that we've come across, but these are the four that probably customers focus on the most across the board. The first is probably the most obvious to everyone. If you're generating electricity on site, you are hopefully reducing your utility bills and getting a hedge on future electricity price increases. That's a big portion of the utility bill savings that that comes about as a result of on-site solar energy. We'll dive into that a little bit more, but that's obviously a critical part of what we do. One thing that I think is becoming more known in the industry or more recognized is the increase in property value as a result. So some of you this may be helpful to you, some may not benefit from it, but roughly, depending on what cap rate you are using, for every $10,000 of utility bill savings every year, the property value increases generally more than $100,000. So that's something that different companies measure and value differently, but I think it's a really important thing to point out because it can add to hundreds of thousands, if not millions of dollars in added property value over the life of the solar energy system. An additional piece here for kind of a benefit that some people care about, some people don't, but certainly we are moving from a corporate perspective in the world to focusing more on sustainability. And that's something that is attractive both to employees and customers. So this is a major marketing benefit. And as sustainability and renewable procurement goals get more formalized, we think that solar energy is a main path to achieving those goals, and it's a benefit all around, both to employees and customers. And related to that is just achieving sustainability goals. I can't tell you how many conversations we have with customers who have facility managers and sustainability managers who have been given goals and aren't quite sure how to hit those. And we see solar as a key way to achieve those sustainability goals, both for on-site and off-site. Okay, we're going to dive into kind of solar energy 101. It's pretty straightforward. I think one thing we like to say is solar energy is actually a pretty boring technology, and we mean that in the best way possible, in that it's very reliable, has very few moving parts, and can be expected to produce energy for decades into the future. So we're going to talk about project types, how it works, and if there's any questions that come up, please feel free to chat them, and Joshua will let us know. Okay, some of you may already know this, but just to start from the beginning, solar PV or solar photovoltaic technology has only really a few parts. The main ones are included in the diagram here. The key part where it all starts is with the solar panels shown on the roof here or on the carport. Those absorb the sunlight and produce DC or direct current electricity. That electricity is then pumped through an electrical conduit to an inverter, which changes the electricity from DC to AC. So think about the band in reverse. It's the easiest way to think about it. And that electricity then flows into the building and is either used by the building if there is electricity consumption happening at that time. If there isn't electricity or the solar array is producing more than the building is consuming, then it is sent into the electric grid. And there's a bunch of different policies on how that is monetized or valued, depending on where you are in the country. But I think the easiest thing to say is that 100% of the electricity produced by the array is counted by the utility. It just depends on what rate you are compensated for. So we'll get in into a little bit more detail about that in later slides, but it's pretty straightforward. Again, no moving parts, very reliable equipment, and pretty straightforward overall operation. In terms of, I'm just going to fly through a few different project examples to give you guys an idea of all the different applications that we've done as a company and are available to you as facility managers. The first is probably the most straightforward. This is a small to medium sized flat rooftop solar PV installation. This is on a relatively new white TPO roof, and the application here is a ballasted system, which is basically just a system that is weighted down on the roof. There are no roof penetrations for this specific installation, and as you can see, there's not many obstructions on the roof, a few small AC units, a few vents we had to avoid, but pretty straightforward design. And the reason we didn't fill up the entire roof here is that we had offset 100% of the annual electricity consumption of the facility. So we have some extra space left over. A few other just applications, very similar, but you can see this is a bit more of a broken up roof, but we're able to utilize nearly all of it. This is at the University of Denver, here in Denver, Colorado. And this is a larger array, but was built in the last year, and similar ballasted system on a newer TPO roof, just split up and connected by conduit. One more version of a flat ballasted roof system. This one, as you can see, there's some larger HVAC units on the building, so we had to avoid those, which restricted how much we could install, but overall, a pretty straightforward installation. The panels for all of these last three projects were at 10 degrees, facing us south as possible. Obviously, slightly different orientations in this one, but pretty straightforward and very easy install, all in all, for these last three. If you have a metal roof or metal roofs, this is a smaller installation at a self-storage facility, but there are straightforward connection mechanisms that do not require any sort of roof penetrations for the majority of standing seam roof applications. This is not at a steep pitch, but you can, in most circumstances, connect solar panels to steep metal standing seam roofs. If you have corrugated roofs, there are applications. There's just a little bit more of a leak risk, but there are still solutions for corrugated roofing as well. This may or may not apply to some of you. If you do have facilities where there are, or you have a lot of land nearby, probably not the majority of you, but if that is the case, there's a few different solutions. This is a unique solution in that it's a ground mount fixed tilt system. This is actually up in Maine, and this is a ballasted ground mount, meaning there aren't any penetrations into the ground. That's because of the specific soil situation here that didn't allow for straightforward pile driving, as we call it. So this is a what we call a fixed tilt ground mount system, and it's not as common, nearly as common as the following slides, but I wanted to include it just as one possibility. This is what is more common for ground mounts, which we call a single axis tracker ground system. This is a project of ours. It's actually an off-site array in Western Colorado. And these panels rotate on a single axis to track the sun from morning to evening. If we look on this next slide, you can see this is more in the evening with the sun in the west, but the panels track the sun to maximize solar energy production throughout the day, which really does improve economics, and the cost of these has come down dramatically. So it's pretty much a no-brainer to utilize these if you have large plots of land almost anywhere in the continental United States. A few more solutions. Solar carports are becoming increasingly common for a variety of reasons. One, they produce electricity at facilities that often don't have as much roof space. This is actually at a data center, so the roof wasn't super available to having a lot of solar panels on it, largely because of HVAC equipment. There's other benefits to using the parking lot areas. You're providing protection from sun, rain, hail, you name it, for cars, for employees and customers. Some municipalities are requiring that parking lots are shaded or covered in one form or another. So if you're already building the structure, it's not that expensive to add additional panels on the top to produce electricity. And there are some benefits to that from a federal tax credit perspective, which we'll talk about here in a little while. This is another carport. This one's just finishing construction, as you can see, but this is actually at a regional electric cooperative headquarters, and this one was done for employee parking. Lots of different designs, orientations, customization options with carports. There's probably 50 different options you could choose from. You can customize them from a painting and color perspective, materials. You can do cheap ones, more expensive ones. You can include electric vehicle charging stations, and then there's lots of ways to customize these for the facility you are using. It is important to note that you are building a structure made out of steel, which is on the more expensive side right now. So it is a premium product based on a comparison with a rooftop array. But if you do value those other benefits, then it's often a no-brainer. One more carport photo that I really like. This is at MasterCard headquarters in New York. It's pretty unique in that it's the kind of a half moon design, not the least expensive option to go with, but this is what made the most sense for where the existing parking garage was and what the customer wanted. So pretty cool application there. Last project type I'm going to cover is architectural features, and these are definitely more niche, admittedly, but I wanted to point them out because they are becoming more popular. These are two separate projects we've done. The solar flower or solar tree, whichever you want to call it, on the right here was something we did at the University of Denver recently in the last year. And they really wanted something to be visible. They did 20 different rooftop installations, but the majority of those were not visible to students, staff, visitors to the campus. They wanted something to be visible to anyone passing by and be useful. So this allows students and staff to actually charge their phones, get some shade, and is right in a major walkway so people see it. That's a pretty cool application. It's not economically in and of itself the best option, but it certainly, coupled with a larger installation, is a good option to increase visibility. On the left here, a little blurry photo, but this is what we call a BIPV, or building integrated photovoltaic system. We're actually under construction on phase 2 of this building right now, but this is basically using solar panels as part of the exterior cladding of the building. So it's not just attaching the panels to whatever existing structure was on the outside of the building. This is built into the main part of the southern and the eastern portion of this part of the building. And it actually reduced costs pretty significantly by using the panels as that exterior cladding, and improves the return on investment for the building pretty notably. So there are a bunch of creative ways you can incorporate solar into buildings. Again, you're not going to see these everywhere. Rooftop is much more common, but these are viable options in large areas of the country. Okay, a few items to discuss on technology. As I mentioned before, solar panels are reliable and pretty boring, and that's how we like it. Most panels, this is generally speaking, but pretty good summary for the entire industry, are warranted for 25 to 30 years. The way that warranty goes is, in general, they guarantee the panels will produce 80% of what they do in year 1 in year 25. So the vast majority of the panels production will still be around 25 years from now. So that's just a testament. These are pretty durable, barring some crazy weather event or tornado or hurricane. They're gonna sit on the rooftops and reliably produce electricity for decades into the future. There are very few ways, if any, that a solar panel itself can malfunction. If you need to replace any equipment in the future, it's really going to be the inverters, and that's generally, we assume in our cash pro forma as in year 15. But those still, the default's kind of 10 to 12 years for a warranty, but you can extend that to 20 plus years at this point if you want it to be covered. And inverters can be placed on the roof near the solar panels, or near the utility meter in the electrical room, or on the exterior of the building. So there is some flexibility there. Talked a little bit about this earlier on the slides, but a few of the most common rooftop racking systems. The first is ballasted, and as you can see here, it's nothing fancy. It's some cinder blocks that weigh down the system and ensure that the panels aren't going anywhere if there's wind. And those come in a variety of different designs. You can see one here, but it sits on top of the roof membrane. In the vast majority of circumstances, you do not need to do any roof penetrations, and it will not void the roof warranty, though that's something that each contractor and developer will need to confirm for each building. If you have a metal roof, as I mentioned, standing seam is the best option there. We have something called an S5 clip, which is the most common one, that just attaches to the ridge of the standing seam roof, and then that's where the racking system is attached to. So pretty straightforward, and again, no roof penetrations, really very little to no risk of roofs leaking, though it certainly can happen in some circumstances, but if the install is done right, there should be very little risk of that. The other piece of the kind of entire solar energy system is the monitoring portion, and this is important. It's not a big cost portion of the overall array that you install, but it's important that you have real-time monitoring, just so you can show how much is being produced every day and calculate that over time, but also know if there are any issues that come up. This would alert you to issues that could arise over time if there's hail and there could be damage to the panels, or there's something that is putting the system offline. This will let you know. There's a variety of different dashboards for different solar energy monitoring, but it's also really helpful for finance systems when we might own it as a company. We'll talk about that. We use these as much as the customers do. Okay, a few items that we just like to touch on for new construction. I'm sure many of you have dealt with new construction before, but it's still similar considerations, but a few other things to look out for. energy consumption is probably the biggest question here. If you're building a new building, sometimes you have a pretty good idea of how much energy is going to be consumed. However, a lot of times that's different than what occurs once it's actually in operation. So that's something that in general we recommend waiting until post-construction to get a good idea of how much the facility is actually going to consume when it's fully operational. We can model very specifically a energy consumption estimate, but there are limitations to that. So we generally recommend waiting until post-construction, but there are exceptions to that can be made. From a structural perspective, if you're doing a rooftop, you need to incorporate at least 4 to 6 pounds per square foot additionally into the structural specifications for the building. This is rarely an issue for existing or new buildings. Existing buildings, that most of them, the developers did not expect to have solar on the building, and we can usually make it work, but it is important to note this to the design team, and this is something that you expect to do during the life of the building. From an electrical perspective, some people are very picky about this. If you have very specific aesthetic design concerns or guidelines for your building, if you are building something you don't want exterior conduit runs, you want to make sure that those conduit runs are built in as the construction is happening through the core of the building as opposed to exterior. That's something that some of our customers feel very strongly about. And then for roofing, the basic solution here is TPO or standing seam are generally the better options for compatibility with solar, but certainly that's not an absolute requirement. There's other roofing materials that we can utilize and install solar on. Okay, last slide here for my section, and I'm going to pass it over to Suparna and maybe see if there are any questions. We get tons of questions about energy storage, and it's fantastic. But I think in general, it's a little premature, for better or worse. This is not a super instructive photo here, but it's helpful. This is a 30 kilowatt energy storage bank, which is the size of like kind of a large electrical cabinet for a bigger building. And I think it's important to note that this is proven technology. Like, energy storage systems work, and certainly they're improving over time. The cost is coming down, but they work as expected for the most part. They still are on the expensive side. They're kind of where solar PV was 10, 12 years ago, before it really started scaling up and becoming a good investment in the majority of states in the country. So we're only seeing this make economic sense in a lot of states with higher electricity rates, California, New York, Massachusetts, and select other states and utility territories. It's possible and makes sense in some other Northeast states, but it's still pretty early on, and it's much more common to see this for residential applications, for single family homes, and for utility scale, the kind of middle ground that you all inhabit in the kind of commercial industrial mush market. It's harder to make these work for a variety of reasons. I'm not going to go into all the details, but it's going to take a few years before this is widely available and makes sense. That's from an economic perspective, which is what most of our customers are driven by. However, there are benefits to energy storage for what I broadly call resiliency, which is backup power and other sorts of non-economic benefits that can come of it. So every customer and building and property is different in what they need, but we will be seeing more and more of this. But it's not like this makes sense in every state for every customer. We're far from that reality. Okay, I'm gonna stop here and see if there are any questions, and if not, I'll pass it over to Suparna to talk about the economics of solar. Joshua, are there any questions, or can we keep moving along here?
You're good. You can keep going.
Okay. All right, Suparna, I'll guide the presentation here, but if you want to take over for these next 3 or 4 slides, we'll go from there.
Thanks, Matt. So there's a couple of key factors that drive this economics for solar. And the most obvious one that everyone's familiar with is how sunny is a place. Most people just automatically assume that solar is best in sunny places like Florida or California or Texas, but are surprised to hear that there's very active solar markets in places like Maine and Illinois. And so that's where these other factors come in. So solar resource, meaning how much sun is available, is one big part of it. Another part of it is your local electricity costs. How much are you able to save in your operating expenses? Throughout the country, it varies. There's some parts of the country where electricity is quite cheap. So putting solar in may not save you quite as much on your utility bills compared to other parts of the country where it does cost quite a bit. So that's another factor. The third factor is your local policy and incentives around solar, and I'll talk a little bit more about that on the next slide, but it's a very patchwork, and this varies across utilities and states and even cities and towns. And then the last driver is your materials costs and your construction costs, which are just subject to the market. Solar has been steadily declining year over year and has gone through dramatic cost declines over the last decade. It's dropped over 70%, and it continues to drop with little blips here and there. So those are the key things that will help determine whether solar has economic benefits for you and your facility. And we can go to the next slide, Matt. So in terms of some of the policies that help support solar, there are federal level incentives as well as state and local utility policies. On the federal side, the biggest driver for some of the economic benefits are a federal level investment tax credit. Right now, that's 26% of the total system cost. It will be stepping down over time. So in 2023, it's going to drop down to 22%, and then 2024, it'll drop down to 10%. So those benefits are highest today. And that's a dollar for dollar tax credit off the system cost. The second federal policy that helps with solar costs is the ability to expense your system 100% upfront in the first year. And so that's another financial benefit for solar. On the state and local side, it varies, as I mentioned, it varies by state, utility, even by city, but some of the things that are in play are renewable energy markets. Specifically, there's solar energy credits for the green attribute from that electricity that are sold throughout the country. Some parts of the country have mandatory markets. For example, I'm in New Jersey, where the local utilities are required to procure a certain amount of solar energy, and that is managed through a solar renewable energy credit. There's other parts of the country where it's not mandatory, but it's optional, and you can sell that credit and get some additional revenues from it. There are also various states and utilities that offer rebate programs, cash rebate programs that are applied to your purchase. And then some places have property tax and sales tax exemptions as well, which can help you save a little bit more. The last piece that Matt had mentioned is a policy called net metering. This is a policy which allows you to send any of your excess solar electricity that you generate to the grid and get credited for it. You know, in the best case scenario, that credit is at the full retail value and would offset your costs, but it does vary by utility, these rules. Next. So there's several ways you can get solar, and there's a lot of financing options available. So the simplest way is just as a cash purchase, like a typical any capital purchase. And that would be owned by your facility or entity. A lot of times we get questions about who manages the O&M for that. And most of our customers who purchase their systems, they don't do their own O&M. They will sign on to a service agreement from third parties because solar is not as familiar to folks and that's not something they want to take on. So we do get asked that question a lot. So cash purchase is a great option for any business or entity that has the capital budget available, and you can get pretty good returns on your investment. Anywhere, paybacks can vary across the country, anywhere from 3 to 7 years, depending on where you are. The next option is an operating lease. This is similar to any type of capital equipment lease. The system is owned by a third party, and then there's monthly lease payments. It's a way to get to ownership if you don't have a capital budget available, or you know, don't have the tax appetite to take advantage of some of those tax incentives I mentioned. Typically, these leases are 7 to 10-year terms. The next third-party finance option is a power purchase agreement. This is another, you know, option that doesn't require any capital or cash up front, and it's really an energy contract. As a facility, you're agreeing to host this system on your site, whether it's on your roof or on your grounds, and you're agreeing to buy the electricity that's generated at a contracted price. So it locks in your cost of electricity for the term of the agreement. And as a facility owner and manager, you don't have to worry about maintaining the system or operating it. You're just buying the energy. And then the very last option, which is available in only select places right now, is a roof lease. And in the places where it works, like Massachusetts and Los Angeles right now, you can get rent revenues for hosting a solar system. And then that solar system is feeding its electricity to the grid. It's sold to the utility. And again, that system's owned by someone else, managed and maintained by someone else, and they're compensating you for the roof rental. So there's kind of a range of options, and there's no one size fits all. We have customers who across their portfolio may choose different options depending on a site constraint or business constraints, and so they all work and all can get you solar, and we're always happy to help look at very different options. So
great, thanks, Suparna. We are going to talk just a few more slides, and then we'll finish up here, and we'll have time for questions if there are any. So let me move us here. Just coming And from what Suparna was covering, we just wanted to reiterate one thing, kind of the most common misconception that we get from people newly interested in solar energy for their facilities is assuming that sunnier places always have a better return on investment, which is the case in some circumstances, but definitely not in all. So what we have here are 3 separate project examples. Disregard the photos, these are theoretical. And this is just a 100 kilowatt system, so roughly 300 panels, similar or exact in this circumstance, same build cost of $225,000. But as you can see, really the most important thing we want to notice is on the bottom, the IRR and payback summary varies pretty dramatically. And I'm just going to take us through each of them and explain why that is the case to give you an idea of some different scenarios. So if we start on the left, California kind of the best solar energy market in the country in terms of volume for decades now. And the IRR here is above 18%, and the payback is just above 5 years. That does not include any state or utility incentives, right? So there's no SRECs you can sell, there's no cash rebates, but the utility kilowatt hour rate is relatively high at 13 cents a kilowatt hour, and the annual solar production is 170,000 kilowatt hours. If you look over at Illinois though, again, similar or the same system size, same build cost, but the utility rate is quite a bit lower at 6 cents, so less than half of what it is in California. And the solar production is notably lower at 135,000 kilowatt hours. So you actually have 35,000 fewer kilowatt hours for the same size system in Illinois. But the IRR and the return on investment is actually pretty similar to California, and that's because of the SREC value and the inverter rebate, which is a cash rebate. So those basically make up for the lower production and the lower kilowatt hour rate. So right now, very similar investment metrics for those 2 states. One quick note here, the payback in Illinois is actually quicker because the incentives are front loaded, but the IRR is slightly lower. So that's just kind of a specific reason because of the incentives and how they're structured. Now, if we go to Arizona, Arizona is generally as sunny, if not sunnier, than California for most of the state. Unfortunately, though, Arizona is not a great market for on-site commercial solar energy. We are doing some projects there, but it's not nearly as common, and that's because there's a relatively low energy cost and there are no incentives. And so that's a scenario where the IRR and payback is notably, or the IRR is notably lower, and the payback is quite a bit higher, closer to 9 to 10 years. So it's just something to remember that geography is not destiny as far as solar energy is concerned, and there's a lot of different options. We encourage you to explore and invest in research for solar energy for your facilities, regardless of where you are in the country. One quick example, basic case study for a large extra space storage facility that we completed several years ago, 330 kilowatts, so right around 1,000 panels. This was a large facility in terms of square footage, so we only used about 40% of the available rooftop to offset 100% of the annual electricity consumption. And if you look there on the bottom, a notable upfront cost of $715,000, but return on investment of 4 years, IRR of 25 plus, and the upfront cost does not include tax credits or the cash rebates, which does take down the cost pretty considerably. So this is a great investment. This was a no-brainer for the customer. And again, this just shows that, Illinois, not the sunniest place in the country, is a really good value proposition for a lot of our customers. Okay, just to reiterate one more time, no matter where you are in the country, no matter where the facilities are that you manage, don't assume that it doesn't make sense to do solar. It can make sense in a lot of places. We've done systems in South Dakota and Maine and these places that don't get the headlines for solar energy, but can still be economically and technically feasible. So these are a few things to look out for. You don't have to have all of these things for it to make sense for your facility, but these are good indicators of whether your site would offer a good return on investment. So good condition roof. We don't want to install solar on a roof that's 25 years old and falling apart. Even if a customer would pay us money for that, we wouldn't do it. It just wouldn't make sense until they get a new roof. If you have a newer facility, newer construction, or has been rehabbed, that's generally a good place to start as well, just because there is a newer roof and just newer equipment, electrical systems all around. This is somewhat arbitrary, but medium to high consumption electric bills are a good place to start. If you're a really small facility that uses kind of residential level amount of kilowatt hours every year, you can still do solar energy, but it's probably not good from a large investment perspective, and we'd probably encourage you to do energy efficiency before you dive into solar for a much smaller facility. If you have climate control of any type, which the vast majority of you do, that is another good indicator that you should consider solar energy on site. High electricity cost, we talk about that per kilowatt hour, so that's not necessarily the blended rate of electricity, but it is still pretty high just per kilowatt hour, not including demand charges, because often solar energy does not affect demand very much. It can reduce it, but the demand side of the electric bill is usually not reduced that much by on-site solar. And then the last two, if the property owner has tax liability, that's often a great thing, though, as Suparna covered. Nonprofits, municipal entities, government entities of any type, nonprofit educational K through 12 districts, for example, we can provide third-party finance solution, but if you want to own it as a cash system, then having tax liability is pretty key. And then if you own a portfolio of sites, whether that's a university or a corporate campus or hundreds of sites across the country, you can usually benefit from economies of scale of doing a large number of sites all at once, as opposed to one site at a time. Those are, again, just guidelines, you don't have to check all these boxes by any means, but if you don't have any of these, it's probably not, we wouldn't recommend that you look into solar, but if the majority of these apply to your facilities, it's probably a good idea to invest some time into looking into solar. Okay, steps you can take to explore solar PV. Last slide here. I think the number one thing is to consider, what are your goals? Like, are there organization or corporate level goals that require you in your job to procure more renewable energy, whether that's on-site or off-site? If the answer is yes, then obviously that means you should explore this stuff. If it's no, it doesn't mean you shouldn't, but we have a lot of customers who come to us who are just unsure about the top level goals, and we find it really helpful that if you have clarity on those within your department, organization, or company, that can really help guide us in helping our customers much more efficiently. So that would be the number one thing. Number two is finding a reliable solar energy developer. The technology with solar energy is relatively straightforward, as we've mentioned, but the incentive structures and the permitting and all of those things can get really complex. So whether that's Pivot or someone else, some other group, we really recommend that you find someone to help you explore the different scenarios and work through feasibility for your properties. You can only do so much yourself, even if you're familiar with solar energy. There's just a lot to cover for the kind of whole life cycle of the solar PV system. The other piece, number 3 here, is timeline. Incentives programs come and go. That's for better or worse the industry we work in. And it's really important to take advantage of them when they do come about. So knowing what those deadlines are, making sure you get applications in and work with your contractor or developer, that's really pretty critical to taking advantage of the programs and getting the best return on investment. And then, the final piece, we can't emphasize this enough, is to really, whoever you partner with, whether it's a small local solar contractor or a larger company like us, even though we're only 60 people, we do have national presence, is really to focus on transparency and ensure there's proper expectations from the get-go. As I mentioned just now, there's not a ton of difficulty in figuring out the technical specifications of most solar energy systems, but the rest of the process can be pretty crazy for customers, and that's what developers like Pivot are here to help you with. But you just have to focus and kind of demand transparency from all stakeholders in the process to ensure you get a good project. I think that's it. We covered it all. Go to this last slide. This is Suparna's contact information. Again, this is being recorded and will be available, and I think the slides will be distributed to others or distributed to the members. But we'll stick around for questions if there are any, and we appreciate the time, and hopefully this was informative for everyone who listened in.
Great. I do have a couple of questions here. And just a reminder to everyone, if you do have any questions, feel free and type them into the question box. The first one here is, how do the panels secure to a TPO or ballast roof to prevent wind lifts, etc.?
Yeah, great question. For ballasted systems, and this is the majority of circumstances, the weight of the cinder blocks or whatever the weighting mechanism is all that is needed to ensure that the panels do not fly off the roof. I've been doing this for 12 years and I have never had an installation after doing hundreds of installations where a panel flew off a roof. So it's a pretty good track record. And again, that's in tons of different states and weather situations. So it just weighs the system down. All of the panels are attached together in each row. So that adds some certainty as well. But that's also why we don't prop up the panels at a higher pitch. It's usually 5 to 10 degrees. The higher you go, if you were to go 15, 20, 25, it acts more like a sail and you would have to require more weight on the ballasting system. So that's a purely ballasted system explanation where there's no roof penetrations or attachments. In some areas, such as California, parts of Florida, you do need to attach to the roof and you would therefore be penetrating the roof. In California, that's largely for earthquake requirements. In Florida, it's hurricane related items. So that can add a marginal cost to the array and increase leak possibilities a bit, but that's a pretty solid system that has been figured out for those and would be done by a roofing contractor in the majority of circumstances.
Thank you. Are there building height restrictions for installing solar on rooftops?
Great question as well. Short answer is, I guess, no and yes. When we start getting above 6 to 7 stories in most jurisdictions, you're going to have increased requirements from a structural and attachment perspective. And that's largely because of wind load. Wind load increases. I am not an engineer, to be clear, but wind load does increase the larger and taller the building is. And so in those circumstances, again, it might just be a simple attachment to every other panel or for certain parts of the racking system. We have had a couple customers come to us who I would describe as having skyscrapers, and they want to put a small 10, 20 kW system, 30 stories up, and is that impossible to do? Probably not, but not something that I think any sane contractor would try to complete. So as long as you're not dealing with skyscrapers in very urban environments, you should be able to do it. There just might be a few more attachments or items you have to do to ensure that they don't blow off.
Thank you. We have a couple more here. It says, are PV systems efficient in non-TPO scenarios? And then fully adhered black EPDM.
What was the second part of that question? I missed that.
It just says,
the question was whether
it says fully adhered
on EPDM roofs as well, which they can be, absolutely. As Matt mentioned, it's generally they're ballasted, so they're just resting on the roofs. With TPO roofs, since they're white, you get a little bit better performance from your solar. You can produce a little more energy, but solar is equally fine on an EPDM flat roof.
Thank you. And then another question is, can solar be considered to bypass the need for battery-powered emergency lighting systems?
The short answer is no. So something we didn't cover was, if you just have a standard solar PV system without a battery attached and the grid goes down, unfortunately, the solar array also goes down. And that's largely for safety purposes. Local fire departments or emergency services don't want electricity being pumped back into the grid at random places if there are power lines down from a storm. So if you don't have battery storage, then the system shuts down when the grid goes down. There's sensors in the inverters that will do that. In the circumstances there is battery backup, you could potentially have enough energy in the energy storage system to supply critical systems to the building, whether that's life safety or whatever it may be, certain circuits. For homes, that looks like usually powering a refrigerator and other, basic services. So people with the large Texas outage that happened earlier this year, there were people who had battery backup systems that could easily power a refrigerator and quite a few other devices throughout the day, and that's recharged from the panels and what they produce during the day, and then they use that at night. So yes, you can power life safety systems, however you want to call it, with solar, but it does absolutely require energy storage as part of that solution.
Great. That was our final question. If at a later time you do come up with any other questions, certainly feel free and reach out to Suparna. Her email address is on the screen right now. And at this time, are there any last words that either of you like to say before we close out the presentation?
No, we again, we really appreciate it. Thank you for the opportunity to talk with you all. We hope this was informative and helpful, and please don't hesitate to reach out to Suparna if you have any questions about our presentation or anything else that you think we can be helpful with.
Great. I want to thank Pivot Energy for providing such a great presentation for us today. Thank you, Matt. Thank you, Suparna. And I want to thank all of the attendees. Have a great rest of your day, everybody. Bye-bye.